All right, now that we know how to convert from base 10 to base 2 and base 2 to base 10, we're going to learn how to do some basic arithmetic with binary numbers. So think about how we add numbers in base 10, and before we get to the details over here to understand why 1 plus 1 is really 1, 0, let's think about how we add in base 10 and the issue of carrying that we have. If you wanted to add 29 plus 17, when you go to add the 9 plus the 7 here, you get 16, right? Which is really 1 times 10 to the first plus 6 times 10 to the 0. Okay? So we can put the 6, and then this 1 has to get carried over to the tens place, which happens to be right here. So we add basically 10. We just put the 1 up here, assuming that the 0 is there. We basically just add 1 to the tens digit and put the 6 down here. And then we can add straight down here, and we'll get 46. Okay? Now, when we try that in base 2, when we add 1 plus 1, we get 2. And 2 base 2 is a problem, right? We can't really put the number 2 in base 2. So if we want to represent the number 2 in base 2, right, we know that the powers of 2 are 1 and 2. We'll have to represent that as a 1, 0. So whenever you add 1 plus 1, you're going to get a 0, carry the 1, and since there's nothing left here, the 1 comes down, and that's why we get 1, 0 in base 2. We don't read that as 10, right, because 10 means the number 10 in base 10. We want to read that as 1, 0. 1 plus 1 in base 10 is 2. 1 base 2 plus 1 base 2 is 1, 0 base 2, which is also 2 in base 10. Okay? So let's take a look at a little bigger example. We're going to have to write this out. We probably want to do this vertically, and we want to be a little bit careful to keep everything lined up as best we can. Now, I don't know, I'm not going to be too particular about you writing all the 2's over here once the problem starts off in base 2, and if it's all 1's and 0's, we're going to assume it's base 2. Okay. So let's see what happens. We're going to start with the first situation here. When you add two numbers, you're either going to get two zeros, a 0 and a 1, or a 1 and a 1. We know that when we add 1 plus 1, that gives us 2, but we can't write 2, so we put the 0 down and carry the 1. Okay. Now, once we decide to go to the next digit, now we have to add the 1 and the 0 and the 1. Again, that gives us 2, but we can't write 2, so we put a 0 and carry the 1. And now we have a new problem that when we get over here, right, we really have a 1, a 1, and a 1. How do we write 3 base 2? Well, we put a 1 in the 2's digit and a 1 in the 1's digit. So in this case, we would put a 1 here and carry the 1 up here. Now, this 1 plus 1 over here is going to be 0, 1. Then we carry the 1 again. 1 plus 1 is 2, 0, 1. And then finally, when we do this, we get 1 plus 1, which would be 1, 0. And if we take all the colors out of this to make it a little easier to read, this is the number we get as an answer. Now, if you wanted to check this work, right, you could always convert this to a base 10 number, this to a base 10 number, add them, and see if that's what this ends up being as a base 10 number. Okay? So basically the rules are, if you have 2 base 2, you have to write it as 1, 0. If you have 3 base 2, you're going to have to write it as 1, 1. Now if you had 4 base 2, then you would have to go to a third digit here, 4, 2, 1, and put a 1, 0, 0. Right? And if you had to add enough numbers in base 10, you could get to 100, and then you'd have to carry over 2 decimal places instead of 1. All right? So let's see what happens with a problem like this, where we have 3 numbers that we're adding in base 2, 1, 1, 0, 1, 1, 0, 1, 1, and then 1, 1, 1. Okay? Again, we're going to start in this left column here. 1, 1, 1 is 3, so we're going to put a 1 and carry a 1. 1, 1, 1 is 3, we put a 1 and carry a 1, put a 1 and carry a 1, put a 1 and carry a 1. This is our answer right here. If we had bumped ourselves up to 4, we would have had to move a 1 2 places over and then just carried an extra digit over, right, but not to the left, immediate left digit. Okay? So Practice these. Most of the time you'll just be dealing with 2s and 3s. When you add a bunch of binary digits, occasionally you might get up to 4 or 5 if you had enough numbers in a row here like this. But chances are you'd be okay, right? If this was a 1 here, then you would have had a 4, and then that would have been a 0 here, a 0 here, and a 1 over here. Okay? Now we're going to tackle arithmetic much the same way. Let's review again how we do arithmetic, multiplication. Sorry, I think I said arithmetic. We're talking about multiplication here in base 10. Right? First thing you do is you multiply the 7 through each of these. Right? 7 times 9 is 63, so you put this 3 and carry the 6. Same idea as with the addition. 7 times 2 is 14 plus 6 is 203. Now, what do we do with this 1 here? It's not a 1, it's really a 10 because it's in the tens place. So we add a 0, and then we do the 1 multiplied through, and we get the 29, and then we add down. And that's how we do multiplication in base 10. So we're going to have to model that in base 2. We're going to start by multiplying the 0 up here, 0, 0. And then because this 1 over here is actually in the second space, right, we're going to have to put a 0, and then we're going to do the 1 and the 1. Now again, the nice thing about working in base 2, right, you don't really have any fancy arithmetic to do. Multiplying by 1 or 0 are the only two options. So you're either going to copy down this bit string or copy down a row of zeros, but then you still have to add, and you'll get 1, 1, 0, base 2. Now we know that this number is really what? 2 and 1 is 3. We know that this number here is just 2. 3 times 2 is 6. And this is 4 plus 2, which is 6. So it's an easy way to check that if, in fact, you want to do that. Right? It's probably a good idea, especially if you finish with enough time to do some practice conversions on these small bit strings. Okay? So now let's do another slightly larger example. You'll practice more of these. Again, don't worry too much about writing the base 2. If you're given a problem in base 2, there's probably no reason to actually put the little subscripts of 2. Okay? The 1 comes through here, right? It's going to copy the bit string down. I'm going to indent a space, and then 0 comes through, so I put a row of zeros. And now I'm going to indent 2 spaces for this one. That one's going to come through. And again, because all I'm doing is multiplying by 1, I'm just going to copy that down. I'll make these a little bit bigger. They got a little bit scrunched at the bottom of the page. Right? And now I just have to add all of this up. Now again, I follow the rules for adding. I'm going to have to use the same carrying rules like I did before, because this is now an addition problem. When I go down this column, I get a 1. When I go down this column, I get a 0. When I come down here, I have 2. So I put a 0, carry the 1. That gives me 2 again. I put a 0, carry the 1. That gives me 2, carry the 1, 0, carry the 1. And this will be my final answer here. Again, if you want to check it by converting these both to base 10, you could do that. And then you could check this answer here. Okay? Multiplication, again, it's really just either the bit string itself or a row of zeros. You just have to remember to indent for every space, just like you do in base 10. So it shouldn't be anything all that new. It just takes going through the motions a few times. Okay. Now this can be done in any base. You have the same issues. If you were doing base 8 with addition, then if you added a 6 and a 4, that would give you 10. You'd have to represent the number 10 in base 8. It would take up 2 digits. You'd have to carry something over. For our purposes this semester, all we're going to deal with addition and multiplication is base 2. But from a computer science standpoint, if you're writing an algorithm, you should be able to generalize it for any base. You just have to change the formula or change the calculations a little bit. Okay, so give this some practice, and you should be in good shape.